Hi everyone, it's me. I was looking over your responses to the Nearpod, and I noticed that you there were a couple things that repeatedly kept coming up, so I wanted to make sure I went over them. The questions from the Nearpod were all taken from this worksheet that you got on, well, I think it was yesterday, Monday, yeah. So I figured we'd just go through and answer these like we would if we were in class together. So let me first of all get this so you can see it and it's not blurry. I think that's good. All right. So first of all, let's talk about these formulas for the mean of a binomial. The formula for the mean of a binomial is n times p. So you want to take your n, which in this case for this problem is 30, times your probability, and the probability of flipping a fair coin is 50-50. So the probability of this one would be 30 times 0.5 or 15, and that makes sense if you think about it. About 15 times out of 30 you should get heads or tails. Interpret the mean, the average number of times it will be heads is 15. That's how you interpret the mean. The next one is the standard deviation. Standard deviation is the n times p times 1 minus p, and then you're going to take the square root of that. So in this case it would be 30 times 0.5 times 1 minus 0.5, and take the square root of that. Put that in your calculator, you should get 2.74. So to interpret that, we would say the number of heads will typically vary from the mean of 15 by 2.74. All right. So you all did your 30 coin tosses and you recorded your number of heads. Lots of you went on to the discussion post and posted that, and I appreciate that. That helped me to make the dot plot, which was what I showed you on Nearpod. Okay, and it was a good dot plot. Let me see if I can pull that up for you real quick. So hopefully you can see that, but this is the dot plot we came up with. That wasn't everybody's data, it was just all the data I had at the moment that I made this dot plot. So a few of you entered your data after that. And I think if we would have added all of those points after the fact, you would see that it would start to stack up even more here towards the middle. So we have that. All right, so back to this. So what is the approximate shape of the sampling distribution? It's roughly symmetrical. And the word we use for that is going to be normal. It's going to look a little bit like the normal curve. Okay, so, and that's going to happen because of the large counts condition, which we'll talk about here in a minute. But let's talk about number 5 first. All right, so on number 5, let's think of the sampling distribution as being a normal distribution using the mean of and the standard deviation from number 1, draw a picture, and then find the probability of getting 19 or more heads. So the picture that you should have drawn would have looked something like this. And you didn't have to be super exact, but we're saying that getting 19 or more heads, so all of this piece right here. And since 19 is in between 2 standard deviations, we would have to find a z-score for that. And remember, your z-score formula is x minus mu over the standard deviation, which is 19 minus 15 over 2.74. And if you put that in your calculator, you get 1.46. And what we need to do is find the area using the table A. But remember, table A does only the left side. This is on the right. So we have to take and find our z-score. I posted the z-score sheet for you. I'm going to grab this one from this textbook that I happen to have at home. And we're going to look up 1.46. So you can see 1.4 is here, 1.46 is here, 0.9279. So I'm going to take the 0.9279 and subtract it from 1 so that I can get this little piece right over here instead of all of this over here on the left. And that's going to give me 0.0721, or in other words, 7.21%. All right, so with 19 heads out of 30, would we have convincing evidence that the coin is unfair? Explain. We would not have convincing evidence, and it's because of this number right here. So what you would say is, no, the 7.21% is greater than 5%. And that means it's not statistically significant. And we know that if things are not statistically significant, they could have just happened anyway by chance. So we can say that the coin is fair, or we have no evidence that it's not. So those of you that flip coins, flipped real coins, those of you that used a simulator used a simulation of a fair coin. That's what we can conclude with this particular exercise. Well, I think maybe we did have this question on here, but let's do this. If you have this sheet, you can fill out the important ideas, which are the learning goals for this unit. So the first important idea is that to find the mean, you have to take n times p, and to find the standard deviation, you have to take the square root of n times p times n minus p. And that to interpret, you have that script of the number of blank typically varies from the mean of blank by blank. That's your script. That's your interpretation. Important idea number 2 is the large counts condition. Your large counts condition is that if your n times p is greater than or equal to 10, or if your n times 1 minus p is greater than or equal to 10, then your sampling distribution will be approximately normal. And finally, and I'm running out of room because I'm trying to write big enough that you can see, we have idea number 3, and that is, don't forget that z-score formula. So you have your value minus your mean over your standard deviation, and that once we get that, we have to use table A to find the percentage. And don't forget, sometimes you have to subtract that from 1, depending on if you're trying to get the right side or the left-hand side. So these 2 questions right here were on your Nearpod today, and again, we had a lot of questions on how to answer those, so I wanted to make sure that we covered that. So about 10% of people in the United States are left-handed. Suppose we take a sample of 120 residents and let x equal the number of residents who are left-handed. Calculate the mean and standard deviation of the sampling distribution of x and interpret the standard deviation. Okay, so let's talk about the mean first. So to find the mean, we have to take n times p. In this case, n is 120 and p is the 10%. So to find the mean of this distribution, you're going to take n, 120, times 0.1, which is equal to 12. To find your standard deviation, that's where you take n times p times 1 minus p and take the square root. So my standard deviation in this case is going to be the square root of 120 times 0.1 times 0.9, which is going to give you 3.29. And to give the interpretation of that, we would say the number of left-handers, always in context, this is important, the number of left-handers in a sample of 120 typically varies from the mean of, in this case, 12 by 3.29, which is the standard deviation. And the next thing is to justify that that distribution of x is approximately normal. So in order to justify this, we have to use the large counts condition. So analyze this. N times p, is that greater than or equal to 10? So 120 times 0.1 is equal to 12, and 12 is greater than or equal to 10. And n times 1 minus p, is that greater than or equal to 10? So I have 120 times 0.9, which gives me 108, which is also greater than or equal to 10. So it does satisfy that. So basic, when it says justify, this is what you need to include, this information right here. Okay, hopefully that cleared a lot of stuff up for you guys. Tomorrow in the Nearpod, it's going to ask you these other two questions to, or questions like this, to calculate the probability. So you're going to have to use the z-score formula. So I'm going to go ahead and cover this right now, because you're going to be asked not these exact questions, but questions like it tomorrow. So for this one, you always want to start by drawing the curve, drawing the mean, and it's asking for anything greater than 16 or 16 or more individuals. Remember that your mean was 12 and your standard deviation was 3.29. So to find the z-score, I would take 16 minus 12 over 3.29, which would give me a z-score of 1.22. Since it's an area and it's on the right, that means I have to do 1 minus that. So again, I'm going to pull out that z-score sheet in the book. Okay, you'll look on the positive side for 1.22, which is 0.8888. This one right here. So minus 0.8888, which would give you an area of 0.01112. Oops. 0.1112. Okay, so what is that, 11.12%? So interpret your answer from number 3. When taking a random sample of 120 U.S. residents, there is an 11.2% chance of getting 16 or more lefties. Okay, oops. So I really hope that helped. I know some of you are struggling. Some of you seem like you're getting it though, so if you're still struggling and you need more help than what I was able to give you here, you may have seen that I have set up a conference call for March 25th. That's tomorrow from 4 to 5. and it'll be a live conference call through Teams. I probably won't have a video up because I plan on using the document camera, which I think is really going to be helpful. And all you have to do is follow the link to get to that. But don't go there till 4 because I won't be there till 4. So again, I hope it helped. Missed you guys, and hopefully we get to see each other soon. Talk to you later. Bye.